let us look at implementation of queue using the arrays. So we know we can implement the queues by two ways. One is by static memory allocation and other is by dynamic memory allocation. Static memory allocation we will be using the arrays. For dynamic memory allocation we will be using the linked list. So we know, so for the implementation of queue there will be two operations, like, right, one is insert and other is delete. So delete will be doing it from the front end and insert will be doing it from the rear end of the queue. And coming to the arrays, we know it's a static memory allocation. So yeah, now we'll be looking at how we'll be implementing firstly this insert. So we'll be inserting node or insert element, we'll say insert element in queue using arrays. Okay, this is the first program let's talk about, and the second thing we'll be talking about the deleting from the front end. So insert element in the queue from rear using array. So let's visualize it, how it will be happening. So this is the queue, right? You know it is known as a, so inserting we'll be calling it as an enqueue. So this is the front, this is the rear of the queue. So we can insert elements. So this is the queue, so this is the front, this is the end, and we can insert element only from here, right? So we'll be writing the function to insert, which is known as a void enqueue. Let's say we want to insert some element, right? Inserting means we need to insert some element. Let's say int, let's say we'll define it with x, let's say int x. So x is the element. So what we're doing here, so we want to do these functions like enqueue of let's say I will be putting 10, and enqueue of, then I will be putting 20, then enqueue of, let's say I want to put 30. So how it will be actually is, so 10, 20, 30, oh sorry, yeah, this it will be. So enqueue of 30, 40, 50, let's say I want to put in this way. So how it will be in the final queue is of this way. So void enqueue. So this is the ultimate thing which we need to achieve here. So whenever we want to insert an element into the queue, it is from the rear. So if it is a situation like there are no elements, first of all in the queue there are no elements, that is if queue is empty. So how we can know if queue is empty? If rear is equal to -1, or we can say or and whatever we can use anything. So and front is also the -1. It means there are no elements in the queue. Whenever there are no elements in the queue, we will be initializing front and the rear to -1 if there are no elements, let's say. So in this case we need, what we need to print off is no elements. So or we can do like this. So we are inserting, right? So this is the condition where we don't have any. So we have created one thing. So we have created one, right? Initially front is equal to rear is equal to -1. Now we have created a we are inserting one element into the queue. So what we'll be doing is that, so I will be initializing front to 0 and also the rear to 0. So this is the 0 index. So this is the front and rear, I am putting it here, and I will be doing in this way. Queue of front is equal to the element which I am passing here. So here as I am passing x, so I am putting as x. Before it, to understand why you use this thing is, let's do it this way. Before let me initialize some of the global things. So what is the global thing that we can initialize is, so one thing is we know int queue of So where q is an array, because we are implementing q using array, so we are using this q with an array. Let us put here size b, let's say n, and let me define the size. Let's define n is equal to 5. So define space n space 5 means, so wherever we are using the n means it will be replaced by 5. So now int q of n is fine, and also I am initializing front to initial to -1, also the rear to -1. So these are the global things. Now we will be starting with this void nq. So okay, so if there is no active element present in the current queue means we will be going to this. If let's say there is only one, the other case is if the queue is full already. So here we took the size of queue is 5, right? So if complete total elements are already filled in the queue, this is the front, this is the rear, so all the elements are filled. So because the size of queue maximum is 5 only, so all 5 elements are filled here, so no new element can't be inserted, it is not possible. So we'll write it that case now. So else if what we say, if front, or we can say like this simply, or rear is equal to n minus 1, that is if here rear is equal to 4, if rear is 4, right, we can simply say printf. So it is a overflow condition, means no new elements can be added into the queue in any other situation. That is there are neither condition like the stack is the queue is empty, or neither a condition like the queue is already full. So in any other case we'll be using these steps. So let's say the queue is this thing. So we have already, this is the front, right? So we have already, let's say 10, 20, and let's say 30. So now rear will be here. This is the total limit. So 5 elements is the limit we took, right? So 0, 1, 2, 3, 4. So we are just writing the program by visualizing this queue only. So this is what we are doing now. So in any situation, so I want to add a new element here, right? So I want to add a new element here. So from the rear side only we can add. So we can add element from here. So what I will be simply doing, I will increment the rear. I will put the rear to here. So what I am doing is rear plus is equal to 1. So I am incrementing the rear by 1, and I will put the rear in the index of rear, in the element I will be putting x. So this is the element which we take the input from the parameters of that function and q. So q of rear is equal to x we are doing, and simply we are incrementing the rear. So then let's say if x is we took as 40, then will be 40 will be present here. That's it. So here simply the nq function is done. Now we will be talking about the dq. So void dq function. dq is something like popping out. So where will be popping out, let's say this is the 10, right? This is the front. Now this is the 20, this is the 30. After insertion, let's say we have 40. So now currently this is the rear. 0, 1, 2, 3, 4 index. So n is 5, you know, we know. So this is the front, this is the rear. So for deletion, so here also we need to check some conditions. If there are no elements in the queue, that is if front is equal to -1, or we can say simply rear is also is equal to -1, then we need to print f like, so no elements are present, no element in the present in the queue to delete, to perform delete operation. Okay, this is the thing we can print. Let's say if there is only one element present in the queue, so there is only one element, 0, 1, 2, 3, 4. So there is only one element, let's say. So if there is one element means front will be here, rear will be here. That is what is the condition, else if front is equal to rear. If front is equal to rear situation is there, then what we can do, simply delete this thing. So we can simply assign front is equal to rear is equal to -1. Simply we can put this, and we can also, before it we can also do this thing like q of front is equal to 0. Even if we write this or not, it's not a big issue. Just before deleting we are just putting replacing the already existing element with 0, and then we are decrementing the front and rear or assigning the front and rear to -1 in any other situation. So in any other else situation means this is the situation. So if this is the situation, what we are going to do is, so if this is the situation, the stack or the queue is neither completely empty or neither there is only one element. So in any other case, what we need to do is that, so we need to delete the element from the starting. So how we can delete? So simply let us take one variable, let's say. Even without variable also we can try this way, I think. So let's say, so we need to delete this thing, right? Or simply incrementing the f, that is front. So if I simply increment the front, what will happen? So front plus is equal to 1, so the front will be here. So before it also we can, if we want to print what is the element that was deleted, we can simply say, so printf deleted element is percentage d q of front. So we can also write this way, so that we are informing which is the element that was deleted from the queue, and then we are simply incrementing the front. So here, even without using any other third party variable, we are simply by incrementing the front variable or the front point, we are simply deleting the element from the starting. So now this is the updated queue. We will be writing, let's say, void main function. So void main, so simply we can test some operations like we can do like nq 10, nq 20. So nq 10 means what will be happening? 0 1 2 3 4, right? So now I want to insert a 10. So initially front and rear both will be -1. So whenever I am using the nq of 10, simply we are incrementing the or assigning front and rear both to 0, and we are inserting element into it, so that is 10. Here 10 is simply the x which we take as a parameter in the nq function. And now when we are performing this operation nq of 20, what will be happening? So here the rear will be increased, right? We know the insertion can happen only from the rear. So here we will be incrementing the rear, and then we will be adding the element to 20. And similarly nq, let's say I have written 30. Here now also the same thing, we will be incrementing the rear, and then we will be inserting 30. Now let's say I want to dequeue the element. So dequeue means it will be removing the delete. So delete from the begin, that is delete from the front, it will be, this operation will be performed. So to delete, what we can do, simply we can make it 0 or increment the front. So simply we can do this, we'll make the element 0, and then we'll be simply incrementing the front. So now this is the active queue, we can say. So only these two elements. So now this will be the 0 index, this will be 1 index by default. So here the index is just for our reference. So yeah, let's say again I want to nq something. I wrote like nq 40. So where we'll be having the 40 means we will be having it here. And let's say I wrote again nq 50. So 50 will be inserted at the rear end. So every time the rear will be incremented, right? Initially rear will be here, after adding 50 the rear will be here. Again let's say I want to add 60. So by the function which we wrote, it will be printed like overflow condition, means no further the stack is full, so it is an overflow, the queue is full, it is an overflow condition, so no any other element is possible to display. If we see here, there is one issue. If you keenly observe, there is one issue. So what is the issue is, even it is vacant, so even one of the element in the queue is vacant, still the queue is showing as overflow. So this is the drawback of the queue. So that purpose we are using the circular queue. In the later class, we will also discuss in detail about the circular queue and its algorithm and program details. So now, as of now, we need to understand that. So after reaching the overflow, so even the element, even there is a vacancy present at the initial elements or before the front, so we are not able to add any new elements further. So this is the main drawback, and there will be also another function like display function. So display, what we can do, so we need to display from the front to the rear, right? So now let me take some random thing like int. So I will be taking some temp, and I will be assigning this temp to front, while so this temp not is equal to what we can say, until rear plus 1. So until this, what we can do is that from front to rear will be printing. So printf %d. So simply we can write elements are %d comma, so we can write queue of temp, and we need to increment it, right? So temp plus is equal to 1. This is in the while loop, this is the whole thing in display. So what it will be doing is that from the front to the rear elements, all the elements which are present will be printed. So this is about the enqueue function, this is about the dequeue function, and this is about the display. Also here we can do something like the peek function also we can do. So peek means it simply returns or displays the first element, the front element, we can say the first element in the queue or the front element of queue. So this, try to do it by yourself. Yeah, this is mostly about the implementation of queue using the arrays. So here we have seen all these functions. In the next we'll be trying to learn the implementation of queues using the linked list.